So you and I, we finished up the last time we were together, going through the pituitary gland, which again, that's the master gland, right? Please come. Thank you. Thank you. Thank you. That is the gland that controls all the other ones, right? And there are a number of different hormones that pituitary gland releases, right? If you were looking for a great summary, that's on page 311, the anterior and posterior lobe. And most of those hormones are simply going to other glands, right? So you have the growth hormone, the thyroid stimulating hormone, the adrenocorticotropic hormone going to the thyroid stimulating hormone going to the thyroid, of course. The adrenocorticotropic hormone going to the what? Adrenal gland, right? So you're comfortable with me that the luteinizing hormone going to the ovaries. Most of your pituitary gland hormones are going to other places to control them, right? A question. You should be comfortable with both. Yeah, you should be comfortable with both. I'll put them either way.
And so, like, for the on the review sheet for like the purpose of the pituitary gland, like for that, you would want just like that it controls other glands, like more specific.
Sure. Controlling other glands is a great general piece for that. You have the specific functions of each of these different guys, but yeah, no, that's a great kind of just overall piece. Yeah. All right, so we're moving on today into the thyroid gland. My hope is to get through a good bit of this stuff today, realizing, of course, that Friday is still our summative assessment. And I'm comfortable with that. You may not be, but I feel okay with that simply because of this. It's a pretty straightforward chapter. Do you understand what I'm saying? If you've read it, if you've done the work, I don't think there's a lot of like trickiness to it. The names are tough, don't get me wrong. Okay? So I'll tell you this. Don't expect that I'm necessarily, how can I say this without saying it? There will be some word banks. How about that? Not that I'll necessarily give you a list, but maybe there'll be some matching, maybe some multiple choice. Are you with me? But you still have to learn the names, right? Because they all look the same. Right? So if you don't actually know, then that's not going to help you any. Okay? So don't rely on that piece. But don't be freaking out about, oh, do I have to spell it the correct way and all that? Make sense? Question?
Does it say reception
Regulation?
Oh, regulation.
Yeah. So what regulates? So
like what makes it secreted?
Right. So for the pituitary gland, a lot of its control comes from where? Oh, come on, friends. Hypothalamus, right? Yeah. Most of that control is coming there. As we move down the chain, right, the thyroid gland, what really controls the thyroid gland? The pituitary gland, right? And there's some other pieces as well. Does that make sense? Because it's all this cascade, all this chain in this endocrine system. Yes, ma'am? As specific as we can be, I would say. I don't think there's much more specific than what you said at the second round there. But yes, as specific as you can be. If there is a specific hormone that is like the precursor to that hormone, you should definitely be comfortable with that. Because again, that's what the endocrine system is all about. That this piece senses that and tells this to release that. That releases this to affect that, etc., etc., etc. Okay, moving on. In the thyroid gland. So this is below the larynx and has these two little lobes. So again, your larynx is here, right? Your throat, like your Adam's apple. Just below that is where this thyroid gland is. If you go to the doctor, often this is a place that they'll feel to see these different glands. They're also feeling up here more for your your lymph system glands. But they're also looking at the thyroid. And you notice it's kind of got three big parts to it. You've got these cells that they call the follicular cells or follicular cells. Those guys surround this area called the colloid. The colloid is basically just an empty space. It's where they store the hormone before it releases it. Okay? And then we also have these extra follicular cells. Extra means outside of, right? Or not a part of the follicle cells. And they have two different functions to them. There's a similarity to that. Yeah, that often there's like a deposit place or a bank where they're storing it. Sometimes they just secrete it immediately and goes right into the bloodstream. It really just depends on. But certainly for the thyroid, that's how it is. Good, that's what we just talked about. The two big hormones for the thyroid are T3 and T4. T4 is thyroxine, and T3 is triiodothyronine. I practiced on that one. It's a tough one, okay? And they have two different functions. They have similar functions. They work together to regulate energy metabolism. Let's keep going here. Let's keep going. It's all right. They together work to regulate this piece, all right? So they increase the rate at which it releases energy from carbohydrates, enhances or increases protein synthesis, right, making proteins, and it stimulates the breakdown of lipids. So those are your basic three groups of food you eat, right? Carbohydrates, fats, proteins, right? So it's working amongst all of these pieces in, which again we call that the metabolism, how your body's breaking down pieces. And they are essential for normal growth and development. Where's the control of this given? What controls the thyroid gland? The pituitary gland, right? It releases that thyroid stimulating hormone that causes these T3 and T4 to be released. So to answer your question, no, they don't really differentiate between T3 and 4 in this, which is fine. Let's keep rolling. The extrafollicular. Oh, yes, ma'am. I'm okay with that. Nope. So we were talking about the follicular cells, right? Oy, pushed it too far. We were talking about these cells that surround the colloid, right? Those guys are producing T3 and T4. The extrafollicular cells, the cells outside of those, have their own function, right? So they produce calcitonin, which lowers the levels of calcium in the blood, as well as the phosphate ions. So this lowers that level. The calcitonin increases the rate at which calcium is stored in the bones. So which of the little bone cells are going to be working hard when you have more calcitonin? Osteoclasts or osteoblasts? Class, it wants to store calcium, right? How does it do that? By making more bone. How do you make bone? You use calcium, right? So the osteoclasts will be stimulated with calcitonin. It's technically not referred to, you said? So I do want you to know about it. It is produced in the thyroid gland. It's separate from those cells that make the T3 and T4, so maybe that's why. I don't remember reading that piece. I have to check that out. But I do want you to know what it is, how it works. Yeah. Sir?
I thought osteoblasts make the bone.
Right.
You said osteoclasts.
Did I? My apologies. Blasts make. Sorry, that was what I meant to say. If it's making more bone, it's osteoblast or making. I'm sorry if I messed that up. Osteoclasts are coming in a moment. It increases the rate at which the calcium is stored in the bones. It's making bone to take the calcium from the blood and put it in the bones. Does that make sense? Make bone. They're creating bone, right? Osteoclast would break down the bone and send that calcium into the bloodstream. But again, at this point, we're saying, hey, no, the level of calcium is too high in the blood. So we need to take some of the calcium out of the blood. We cool? And again, my apologies to go with blasts and clasts. Should know better. Again, that's that negative feedback loop, right? As it gets too high calcium levels, we secrete more calcitonin. until it gets back to normal. Then we stop with the calcitonin. Make sense? And that calcitonin is controlled by what gland? Okay, pituitary, but what produces it? I should have said better. Thyroid produces, controlled by pituitary, right? Good, good, good. Yes, sir. I'm talking more about the regulation piece. So the regulating of that thyroid gland would be the pituitary gland that is controlling it by releasing that thyroid-stimulating hormone. It's a good question. All right, so now we're moving into the parathyroid. What does para mean? Does anybody know? Close. It means close, actually. It means around, like near, right? I'm around, I'm about the thyroid. And if you look at where those guys are located, they're actually just on the posterior side of the thyroid, these little tiny yellow guys. I think your book has a much better picture of it that's there on page 313. They make them red instead of yellow, so they stand out much easier in your textbook. Little guys, right, that are there. Again, these are very tightly packed secretory cells with a thin layer of connective tissue. And what do they produce? Very easy. The parathyroid gland produces the parathyroid hormone. Nice, right? At least they just gave you a regular normal name, right? What does the parathyroid hormone do? Well, it increases the blood calcium ion concentration and decreases the phosphate ion. So are you comfortable it uses osteoclasts to go to the bone? Well, sorry, when it's released, it stimulates osteoclasts to break down bone and send that calcium into the bloodstream. Are you comfortable? It's just exactly the opposite of calcitonin, right? That these two work together in this negative feedback loop. This parathyroid hormone also influences the kidneys to conserve more calcium, so don't pee it all out, and also to have the intestines absorb more calcium when it's there. Yes, ma'am? I wouldn't worry too much about that piece. They often go together. Remember, calcium is a metal, phosphate is a negative polyatomic ion. So often they're together as calcium phosphates. I'm not too worried about that. Calcium is the big piece that we're dealing with. This is just another one of the ions that is dealt with there. And they don't go into too much detail in your book about the phosphate. The calcium is a big focus. All right? Here's a picture that is showing you kind of that negative feedback loop that's there. This is in your textbook, right? Yeah, there we go. Again, on page 313. And again, basically showing you that when you have a decrease in that blood calcium, it stimulates that parathyroid gland to secrete. Once that gets in the bloodstream, it starts doing different things, right? Getting more calcium out of the blood, telling the kidneys to conserve it, don't pee out so much of the calcium. And the same thing with the intestines, absorb more. And that's from the vitamin D that gets activated in the kidneys. I put this in. This is not, if you have the actual slideshow that I posted up on Schoology, this little piece is not here. That's a summary of those two, that calcitonin and the parathyroid hormone have opposite effects, right? Calcitonin decreases the blood calcium level when it's too high. And parathyroid hormone increases the calcium level when it's too low. Does that make sense? So they're working opposite of each other. Again, think of that negative feedback loop. If it gets too high, one comes up. If it gets too low, the other is secreted. Yes, ma'am. So remember, the osteoblasts are going to take calcium from blood and put it into bone because it's making new bone. And how it makes bone is by using the calcium, right? So therefore, if I have an above normal, the calcitonin is going to get the osteoblasts to make more bone, to get the calcium out of the bloodstream. If I need more calcium because I'm below normal, then the parathyroid hormone is going to say, hey, take that calcium from the bone, put it back in the bloodstream. Again, all of this is trying to keep that nice level amount of calcium in the blood. Very important to keep that regulated. Questions there about parathyroid hormone? Is it unhealthy to take away? It's not changing the amount of blood, it's just changing the amount of calcium in the blood.
No, like doesn't it like make your bones weird?
No, because again, you're going to be eating. Now, obviously, if you are constantly low and it's taking from the bone, then yes, that would be a problem. You're correct. One of the things I enjoyed about this textbook a ton, after every one of these glands, it told you in the little orange boxes about what happens if one of these hormones are too high or too low. And what you're describing is exactly would be the case. If I'm consistently having below normal blood calcium level, so it keeps taking from the bone, if I'm secreting too much parathyroid, you have weak bones. You're correct. But again, normally there's this homeostasis of it keeps it where it needs to be. Yeah.
I thought I heard something about like you had this type of bone disorder.
Could be. I don't remember. It could be. Again, there's a lot of things that could go into that, but it certainly could be. Yeah. All right, let's keep rolling. The adrenal glands, where are those guys at? The kidneys. Just on top of the kidneys is where they sit, just superior to them. And you've got two parts to this adrenal gland. You've got the inner part, which we call the medulla, and the outer part that we call the cortex. The medulla is mostly just neurons. They're modified a bit, but it's more like nervous tissue, nervous system tissue inside the medulla gland. And you'll see that comes into play with how this works, what the medulla does. I thought there's a picture coming. Well, here it is. I'll pop it up there so you can see it. Here is that kidney with the adrenal gland up on top. And here they've taken off, they've removed that adrenal gland. You've got the cortex and the medulla. They have these three different zones of that cortex. I am not interested in you knowing those pieces. I want you to be aware they're there, but I will not test you over those pieces. The differences between what two hormones? No, I am not going to ask you to know all the difference between epinephrine and norepinephrine. We'll talk about them here now, but no, you don't have to know that table there, no. Okay, so, did I skip something here? My apologies. Yes, okay. So, the medulla, again, that modified nervous tissue, the neurons that are connected to the sympathetic nervous system. And the adrenal gland is actually made up of epithelial cells that are secreting hormones, right? Glandular epithelium. Yes, ma'am. Beyond the ganglion. The ganglion is like a juncture between neurons in the spinal cord. Yep. So let's talk about the medulla first. Two hormones that the medulla is secreting are epinephrine and norepinephrine. And these guys resemble the effects of these hormones resemble the effect of the sympathetic nervous system. Remind me, please, what does the sympathetic nervous system do? In 3 words. Fight or flight. I was tempted to do my big stomp and yell again. I might wake up Will here if I do that, though, so I don't want to do that. But that's the piece, right? Now, remember, go back to when I did that, right? When I stomped and clapped, you were freaked, right? Did you immediately go back to normal? No, it took a little bit of time, right? So that's because when that happened, some of these epinephrine and norepinephrine were secreted, and it takes longer for those effects to go away because hormones last longer, right? Not as fast working, but longer lasting. There's a big, huge difference between endocrine system and nervous system. Nervous is immediate, right? Turn on, turn off. Hormones last longer. You had a question, Josh, or no? All right. So that's the medulla, the inside part of the adrenal gland. again, that's regulated by the central nervous system. That's what the sympathetic nervous system is a part of that central nervous system. So that's what regulates the medullary hormones, not the cortical hormones, the cortex hormones, just the medullary ones. We move on to the adrenal cortex. And there are tons of hormones that are produced here in this adrenal cortex. It's a very needed, very important piece of your endocrine system, this adrenal gland, this adrenal cortex in particular. But they only really focus on three: aldosterone, cortisol, and the sex hormones. So let's jump into those guys. Aldosterone is a hormone that causes the kidneys to hang on to sodium and also get rid of potassium. So again, we're dealing with these electrolytes in our body. And I'm sure you've seen already how many different systems there are to help control the level of these guys, because it's so important. Your body needs these electrolytes to do everything. So aldosterone is secreted in response to lower blood volume and blood pressure. And the reason why it's doing that is to help increase the volume so that the kidneys will hang on to water and help increase the volume of the things in your body. If you just immediately peed out the water that was there in the kidneys, again, it would continually deplete the amount of fluids that are in your body. Does that make sense? And so aldosterone is helping to maintain that balance, maintain that level. Cortisol, it is a hormone that affects and influences the metabolism of glucose and proteins and fats. So again, carbohydrates, proteins, and fats, the three big things that we eat. Give me just one second. In response to things that stress the bodies and require a great deal of energy in the bloodstream. Okay? So think about you having to do some large task or some endurance kind of something. You need cortisol to be there. When you're stressed, when you're in that kind of fight or flight or something is going on, you need energy. And so cortisol is released as a way to give you access to easy energy. Jordan, your question. What is what? I don't know if that is an anti-inflammatory, because I do recognize the name, but I don't think it's exactly the same name as this. I have to check that one out. I'm not positive. I think it's an anti-inflammatory cream that you're using. What, do you remember what you used? I mean, not you personally, but you would be using if you had it. Yeah. For bug bites. Okay. Norepinephrine. Mm-hmm.
That's for the fight or flight, right?
Mm-hmm.
So which one, they both do the same thing? Like which one gives you the, like, are they released at the same time together all the time?
So there's more, on that table 11.5, it gives you more details about what each of them specifically does, like how they work per se. There is much more to them. As far as what I want you guys to be comfortable with is that they come together working simultaneously for the fight or flight sympathetic nervous system pieces. But there is certainly much more.
And so is cortisol like adrenaline?
It's not quite adrenaline, but it has similar kind of things that it does to it. Cortisol is a stress hormone. Have you seen them doing these research on stress and the effects of stress on the body? How they measure whether you're under stress is the level of cortisol that's in your blood. Like, this is a way that they measure the amount of stress you are under. And if you are under, and again, your textbook has a real nice little piece about this, if you're under stress for a long period of time, it can cause changes in your body, increased blood pressure, heart disease, brain difficulties because of that increase in pressure. So there is definitely pieces that are affected by having that thing too high.
Like, you know how like adrenaline gives you like a boost of energy kind of?
Mm-hmm.
Is the reason that we don't like always have that like maximum amount of energy to like protect the body from like breaking down? Is it not healthy for us to be like that?
Right, absolutely. It's unsustainable. Yeah, definitely. Let's keep going. Here is showing you again that negative feedback loop as far as the cortisol is how it's being produced. the hormones that are controlling it, when it's stimulated, it releases the cortisol, and what does that cortisol do? It starts inhibiting protein synthesis, promoting fatty acid release, stimulating glucose, and as those things happen, less and less of that cortisol is released, as well as the other hormones that control it. All right, the hypothalamus is basically the link between the nervous system, which senses these changes, and the endocrine system that actually produces the stuff to make the changes. Yeah, definitely. And again, same thing we just said, that negative feedback loop, right? That is using that the hormones from the hypothalamus as well as the pituitary gland to control that release. The adrenal gland has sex hormones that it also produces. Again, we're still in that cortex of the adrenal gland. And they're mostly that male type hormone, but it can be converted to the female type. They didn't really give you names for these, right? They just call them hormones, or the adrenal androgens, which is just a form of testosterone, a precursor of testosterone. And what do? They supplement those released. Most of these sex hormones are released by the testes or the ovaries, but these help supplement those. And they may stimulate the early development of those reproductive organs when they aren't actively producing their own stuff yet. Does that make sense? Helping you along that reproductive pathway. Do we need to stand up? Got a lot of heads down, a lot of, like we're tired. And I realize I'm zipping through. Okay, but we're running short on time frame. Feel free to stand if you need to. The pancreas. And you notice we're basically just moving from up going down, right? We're just rolling down the body, going through these different glands. The pancreas secretes hormones as an endocrine gland, but it also secretes digestive juices into the digestive tract, which we would call an exocrine gland, like it's actually producing it out into something else rather than just into the bloodstream. Remember those differences? Endocrine versus exocrine? And you can kind of think of it that way because it's inside the digestive tract, which basically leads to outside the body. That's why they're calling it that. It's a good point. So if we continue on, stop, keep going. They're showing you here is the pancreas. It's kind of right behind the stomach. You'll see this is an obvious one when we do our cats and our pigs. You'll see them. That you've got two different pieces, right? Can you see this guy here? Like the little Y piece there? That's where the digestive enzymes are secreted, right? And then you have this little island of cells. That's really what they called it, the pancreatic isolate or islet, right? The little island of cells. That's what's producing the hormones. Does that make sense? So it's like a two-in-one kind of organ. It's producing the digestive juices here, but then it's also producing the hormones there. Yes, ma'am. It is, absolutely. We're talking about these cells would have some difficulties. You're correct. Yeah, we'll talk more about that in just a moment. But absolutely. So let's talk about, so we've just talked about, here is a microscopic view of the islet of Langerhans. That's the actual guy who found these. I think your textbook uses more the pancreatic islet instead of the Isle of Langerhans. That's fine. Both of those are appropriate names. So the hormones that are produced there, glucagon is the hormone that's there. And that increases the blood levels of glucose. Glucose, carbohydrate, right? Sugar, right? By stimulating the breakdown of glycogen. I know these all sound the same. Glucagon and glucose and glycogen, yeah. They all just mean sugar, right? They're all similar. They're all based upon that name. A glycogen is just a chain of sugars put together, like a polysaccharide. Right? So what it's saying is it wants to break down those polysaccharides into smaller things, into glucose. Why would that be the case? Why would you want that to happen? So we can take that glucose and actually use it. right? Glycogen's almost more like a storage thing, right? Think about you're going on a backpacking trip and you're going to store a whole bunch of bars in your bag, right? You're going off to go to the museum or something and you want to have your lunch with you, right? So you put a bunch of stuff in your bag and then you take out one at a time and you eat them, right? You don't eat all 15 of them at one time, hopefully, right? You spread them out. So all of them together would be like the glycagon, and you spreading them out, breaking off piece by piece, that would be the glucoses. Does that make sense? And what regulates that? The hormone glucagon. Yes, sir? Right. There's a fantastic piece in your textbook that talks about diabetes. We'll get to that in one moment because we have to talk about how these pieces work first. But it very much has to do with the insulin and how the body responds to insulin. And you're right. It does very much deal with the amount of sugar that's present in the blood, the amount of glucose that's present in the blood. So again, glucagon is trying to get you more sugar in the blood, right? By breaking down the glycogen and also getting other non-carbohydrates to be made into glucose, like proteins and fats. Sure, right, absolutely. Yeah, it's kind of like the precursor to the storing it as fat. You're keeping it as glycogen as a way to take other places and then distribute it as glucose. So insulin, this is another hormone, glycogen, insulin. Insulin is decreasing the blood levels of glucose by telling the liver to make more glycogen. So are you comfortable that these two hormones are opposites, right? Insulin is decreasing the glucose level. The glycogen is increasing. Are we cool? And again, it also wants to make more proteins and telling the adipose tissues, hey, make fat, because we're basically taking the glucoses and storing them as fat. Does that make sense? We're decreasing the amount of blood sugar that's present, the amount of glucose present in. And again, it's that negative feedback loop that controls that. And these two coordinate, the insulin and the glucagon coordinate to maintain a relatively stable blood glucose concentration. Here's your feedback loop. You have that in your textbook, I think. Yeah, they're on page 320. That again rolls you through what's going to happen. If you have an increase in glucose, the receptors in the beta cells of the pancreas, they see that. And that says, hey, we need to secrete insulin because our glucose level is too high. That insulin says, okay, take that glucose and let's store it, right? Let's make glycogen. Let's make fat. Let's make proteins. Let's get rid of that from the body, right? So therefore, the blood level of glucose drops. If it gets too low, again, now the alpha cells are sensing that in the pancreas, which says, hey, you need to secrete the glucagon. The glucagon will go to those same places, right? We just stored it as my apologies. It's taking the glucagon and breaking it up into the glucose, right? It's taking it from the fat cells, so you're trying to increase the level of glucose in the body. Are you with me? This feedback loop, that's really what this chapter is all about, these feedback loops. Right, if you're too low. That's correct. Okay, I think that's as far as we're going to make it here, because that rolls us through. If you're on our study guide, we've got just a wee bit left. There's these guys at the bottom, and not nearly as much detail given about the pineal glands and the thymus, the reproductive, the stress hormones. We'll talk about how stress affects you, and then how things interact. 2 classes tomorrow, right? Our regular time frame. And then my plan for right now is to do a Kahoot with you in the afternoon tomorrow on these hormones, what they do. Because again, that's like the main piece of this chapter, how these hormones work, where they're produced, what their effects are. Again, if you look at this, well, that's basically what all these guys are saying. What's the hormone? How does it affect? How do we regulate it? Okay? So that'll be for our afternoon time frame together. Okay, you've got about 2 or 3 minutes here.